Okay, we're going to do a little section. It's a single slide, really. Section 13.2.1, velocity is a function of position. So first, we're going to share the PowerPoint, and then I'm going to switch to my iPad. So, hello. All right, here we go. That's where we left off, and now we have velocity as a function of position. We can see that um, as we stretch or compress this mass on either side of the quiescent position, the zero position, we give it the maximum amplitude, A. Let's say we stretch it. So we stretch it, and the spring potential energy is 1/2 kx Ka squared, not x squared, 1/2 Ka squared. As we release it, it's going to exchange, and we just saw in the Walter Fent video, it's going to exchange between, uh, uh, since it's on a horizontal, there is no gravitational potential energy. It's all going to be spring potential energy. So it's going to exchange between kinetic energy and spring potential energy. The spring potential energy determined by where we are on the x. Now let me go to where this may be trivial for some of you. I don't know uh, if it is or not. I don't want to assume that everybody knows how to get to this. Um, and there it goes. So we have 1/2 Ka squared, which is the spring potential energy, and we have the 1/2 mv squared, and we have the 1/2 kx squared, where x can be any position, and that's the idea, is to figure out the velocity when you're at any position. So the first thing we do is we get rid of the halves. We multiply both sides by 2, and we end up with Ka squared equal to mv squared plus kx squared. So now we subtract, we have Ka squared minus kx squared equal mv squared. Now we can, using the distributive property, we can take that k out of the equation. We have Ka squared minus x squared equals m over v squared. Now let's move we divide both sides by m, but I'm going to move the v over to this side. V squared equals to k over m a squared minus x squared. Now if we get take the square root to get v equals the square root of km times, not necessarily parentheses, a squared minus x squared. And that's how they get the, let me go back here and share the PowerPoint. And now that's how they get the, I forgot the plus and minus, but it is plus or minus because the square root can be either positive or negative. V equals plus or minus the square root of km over a squared minus x squared. And we'll see this in the following lecture section. But the point is that you can determine the velocity at any point by knowing the x position, because it's an exchange of spring potential energy and kinetic energy. If you know what the spring potential energy is by knowing the x, you've got the velocity, and that's the idea. You can determine the velocity knowing that the a is not going to change. That's your maximum amplitude. You can use the x to determine the current velocity. All right.